The terminal below is the same. For example, some PC wireless devices. Telephone. Including some of the calls we dial. And some of our internal servers, etc. These terminal devices. There are also printers and cameras. That can be accessed. Connected to our access layer device. Connected to the device at the access layer. Then the access layer we are talking about. What equipment will be used here? We'll use our layer 2 switch. Let me just tell you here. These devices are generally at the access layer. What they do? It is to connect our terminals to them. For example, there are hundreds of employees. Or hundreds of employees in a company. These employees will have access to the internet on their computers in the future. How does it get on the computer? At least I need these computers. Get it together first. Then make it an access. Equivalent to I'll take it. All one network cable is plugged into the computer. Plug the other end into the switch. Just hook it up first. Later, my data traffic will go out. Take the lead from my switch and go to the internet. At least the terminal comes in first. This is what the access layer does. Access more terminals. That's its mission. Generally speaking. We will learn some technology in the future. For example, snooping of DHCP. We usually do this at the access layer. We'll learn its configuration in your IP. On the internet, we will have a corresponding aggregation layer. Does anyone know what an aggregation layer is? What is the aggregation layer? The aggregation layer aggregates access devices. I will give you an example. For example, this is our terminal. 1 by 1 PC. Very many PCs. Then this is our terminal. Assuming that as our access layer. This is an access switch 1 by 1. There may be dozens of PCs connected to each switch. But is it necessary for the aggregation layer to exist? It cannot exist. First of all, let me tell you about the aggregation layer. It is mainly to aggregate our access layer into one. Everyone can see. It only provides a layer of transit capability in the middle. If there is no aggregation layer, this layer is almost gone. Is it possible? Also. But if there is no aggregation layer, can we connect directly to the core layer? Can also. But what if you have a lot of employees in your company in the future? We know that enterprise machine switches are generally 48 ports and 24 ports on each switch. You're going to need some redundancy. Is it a redundancy? You can't run out of interfaces. For a large enterprise, you may be hundreds. You can't put all the access switches. All are connected to this router on the egress dot. Can you understand this? Is that not very optimized? And we're going to make a backup. Relatively speaking, we are not so optimized. So what do we actually aggregate at the aggregation layer? It is more to gather our layer 2 access equipment. Generally, we also do some configuration at the aggregation layer, for example. Some gateway configuration. Configuration of some device gateways. Including some OSPF configuration. Including some DHCP configuration. We send some addresses. We'll all do it at the aggregation layer. It's just all the stuff in here. We may not all learn in NA in the future. Configuration including VRRP. We usually do it at the aggregation layer. You will learn these in the future. Only. Not something we have to learn at this stage. The aggregation layer is generally a switch here. It's just a layer 3 switch. Okay. Layer 3 switch. Everyone can see. It supports us to run routing protocols such as OSPF. It is a layer 3 switch. Below is a layer 2 switch. It is good for us. First, let me tell you, we are actually teaching more for a small business network. So for this architecture, don't think it's complicated, because it's learning slowly. It is not something you must be required to master at this stage. Let's go up. Further up is the core layer. For the core layer, it has a more important mission. In fact, it is also a mission called high-speed forwarding. Core layer. It's like being a senior leader of your company. Senior leadership in general. Think about it as the decision-making level of the company. They all belong to senior leaders. Senior leadership. They are not very busy every day. Do some low-level things. For example, counting the attendance of lower-level employees. This is what the access layer does. It's the work of some people at the grassroots level. The middle layer of the company is like the aggregation layer. Manage company affairs. For high level, focus on making decisions every day. The same is true for the core layer. What do we usually choose for core equipment? To be honest, many companies will buy firewalls at the core layer. Here we draw the router. But everyone will know. In fact, many enterprises use firewalls at the core layer. Why? Because of the firewall. The firewall itself. It has a lot of routing functions. That is, basically for a business, routing functions that enterprises need to use. Firewall devices are basically supported. Second, it also provides security. That is, if I buy a router separately, then if I want to ensure some security of the internet, defend against attacks from the WAN, I have to buy the firewall separately. So now, very many firewalls, regardless of the manufacturers, they all naturally come with many routing functions used in the enterprise. So in the core of the export here, in many places, the firewall is actually directly used. Only larger enterprises will use routers. Then it will go to the external firewall again. So this is what we're going to talk about. Some of its architectural issues. All of these need to be understood. Let's say one last thing. That's the problem with the server cluster. That is, there will be some servers in our enterprise. In the future, we will learn some safety, some trust zones, DMZ. All of these will be learned in the future. But it's safe, because here it is also drawn. Firewall. So for our current equipment. For us now. Suppose we also have firewalls here. Because of the exit here we have a router. Including routers can now also to some extent implement some of our corresponding security policies. It's all okay. We can also deploy security policies on firewalls. Externally we can also provide relative access service and ensure the security of the server. It's all doable. This is our overall communication architecture. So for large networks, it actually does better. The first point we call redundancy. What is redundancy? You can see each aggregation layer. Do I have 2 devices? Every device at the access layer. Is it all connected to the gathering? It is equivalent to if a device hangs. Change a color. If the device hangs. In the future, I can still go this way. Our core layer is also 2 devices. Your device will hang up. My traffic can still go this way and then go out.